Okay, let's do domain and range. I'm gonna get rid of this one. Maybe. Okay. So the domain starts all the way at the left at negative infinity and it continues to the right to positive infinity. And it looks like the range is the same from the bottom, negative infinity, to the top, positive infinity. Domain and range will always have the smaller one first and then the bigger one. So they're never going to be switched. The answer is never going to be infinity, negative infinity. So if you're ever wondering, like, I wonder if I got it right, it should always be the smallest one and then the biggest one. The x and y intercepts would have been hard to solve for in a pre-calc class if you had to solve without a calculator. But luckily we are in Algebra 2, so you can just click on them. So when I put 0 for the y, when I put 0 for the y, yes, I get negative 0.704 for the x. I'm going to put that on my paper. So my x-intercept is negative 0.704, comma 0. And then my y-intercept is nice. When I put 0 for the x, I get 1 for the y. Is this function increasing or decreasing? It's increasing. And it's increasing over its entire domain, so you can use the numbers from your domain. And then the end behavior is going to really match the end behavior of the parent function because it still goes from as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity. Just a minute. Let me get this down. So let me switch it over now, and then I can take some questions. My inflection point was here, and it shifted right 1. What did the negative do to my graph? Let's see what it looks like without the negative. That's what it looked like before, and then if I put the negative back, what does the negative do to my graph? And the word we're going to use is reflect, okay? So the negative reflects your graph, the minus 1 shifted at right 1, and then the 2 does the same thing that the 3 did in the last graph, which is that it vertically stretches it by 2. Let's try to get those words on the page here, okay? All right, we said the negative is a reflection, and I'm going to say specifically it's a vertical reflection. The 2 is a vertical stretch of 2. And the minus 1 shifted your graph right 1. All right, now notice this was the cube root function. This is the square root function. They have different parents, the cube root and the square root. They're both on the front page. Remember, the square root's going to have an endpoint. If putting a 2 in front stretches your graph, what do you think putting a 1/2 in front is going to do to your graph? Yeah, and we call this vertically compress. Vertically compress your graph. So the graph is vertically compressed by 1/2. And I know that before I even graph it because I can see that 1/2 there. All right, if a minus 3 shifted my graph right 1, if minus 1 shifted my graph right 1, the minus 3 shifts my graph right how much? This graph shifts right 1, this graph shifts right 3. And the plus 4 shifts your graph which way? I heard 1 vote for up. Anybody else for up? Yeah. So the plus 4 shifts your graph up 4. Notice I never even graphed it because they always happen in the same place. Underneath the root, if you have a minus, you go right. If you have a plus, you go left. Outside of the root, if you have a plus, you go up. If you have a minus, you go down. In front of the root could be a stretch, a compression, or a reflection. So I'm going to try graphing this before checking on Desmos. It's a square root, so it's going to have an endpoint. The endpoint is going to go left 4 and down 1. So I'm going to go 1, 2, 3, 4, down 1. So I move my endpoint left 4 and down 1. And then I could copy the shape from the parent function, but I notice this negative here, which is going to turn it upside down. So my shape is going to be down this way. To find the exact points, I'm going to refer back to my parent graph real quick. Okay, so here's my parent graph. My parent graph from the endpoint was over 1 and up 1, but I know this is going upside down, so it's going to be over 1 and down 1. From the first point, it was over 4 and up 2. So from the first point, over 4 and down 2. And from the first point, over 9 and up 3. So I can go over 9. And then I can go down 3. Now, you don't have to be able to do that right now without Desmos. You can get all those points from Desmos. But it's kind of nice to be able to. All right, and we did all of that with transformations. I'm going to list the transformations down here that I did. And you guys, if you haven't yet, fill in your other values. So I shifted left 4 and down 1. And I did a vertical reflection. All right, my domain starts back here at -4, and it goes till infinity. My range does not start at the endpoint. My range starts at the bottom of the graph. And what's at the bottom of the graph? I heard negative infinity. Who was that? Is that Brenda? Nice. Okay. My range starts at negative infinity. Yeah. You want to see this part? Okay. All right, look at your range, guys. I guarantee that some of you started your range in a different spot, and this is the right spot to start it at. It starts at your smallest value, which is negative infinity, and it continues up to your highest value, which is -1. Negative infinity up to -1. What's your x-intercept? Well, we don't have one. So remember, 0 is a number, so we're just going to write none, okay? But we do have a y-intercept, and I think it's 0, -3. Can anybody confirm 0, -3? Is that right? Okay. Is this graph increasing or decreasing? One vote for decreasing. Anybody want to agree? Okay. So this is the first time we had a decreasing graph, but still it's decreasing over its whole domain. So we're going to circle decreasing, and then we're going to use the numbers from the domain, but we're changing them to parentheses. All right, and behavior. As x goes to infinity, y goes to what? Thank you. Negative infinity. And then on the left side, as x goes to, what's it going to? -4. As x goes to -4, the y is going to -1. Does this one have an endpoint? Has an endpoint, and the coordinates are -4, -1. All right, just one more until we get to do the fun one. Looking at number 6, what is the transformation that's going to happen to our cube root function? Is it stretched? Does it shift down? Does it shift up? Does it shift left? Does it shift right? Does it reflect? What is it? I heard one vote for shift down. I see one agreeing. Anybody else? 2 agreeing? Yeah. All right. All right. So this one has a point of inflection that's going to shift down 3. And I can actually build that graph just from my parent function. Look here. I know my point of inflection is down 3, and then I can go over 1 and up 1, Back one, down one. And so going back to my point of inflection, go over 8 and up 2. And then over 8 and down 2. And so it's really going to look like the exact same shape, except the whole graph got shifted down. And it's okay if you have to get those points from Desmos, but it's nice to know how to get them without. All right, your domain and range didn't change. I can see my x-intercept on the graph, but I might have to go to Desmos to find my y-intercept because it's way, way out, right? So my x-intercept is 0, -3. Did anybody find the y-intercept yet? 27? Yeah. So the y-intercept is, well, I did this backwards, didn't I? Wait, that's my y-intercept, right? Why do I keep doing those backwards? My y-intercept is 0, -3. My x-intercept is 27, comma 0. Because I put them in the wrong place. So my y-intercept is 0, -3. The entire graph is increasing, so it's increasing over the whole domain, -infinity to infinity. And your end behavior is just kind of the most boring end behavior because we've had it on a lot of problems. As x goes to infinity, the y is going up, so y goes to infinity. And as x goes to -infinity, the y is going down to -infinity. Does this graph have an endpoint or a point of inflection? Point of inflection at 0, -3. Okay. If you are done with all of that and you're ready, you are going to go into Schoology to open the blank copy of this assignment and click this link. Because we're going to see if we can match a function to the bottom of the rainbow and then another one to the top of the rainbow.